Hello and welcome everybody. Thank you for joining us. Welcome to this session on our IBM Developer Europe Crowdcast channel. So my name's Miriam Oglesby and I'm running our IBM Developer Meetup and Eventbrite platforms in Germany, Austria and Switzerland. I'm in my home office in Berlin, Germany. And we'd love to make this session interactive, so let's get the ball rolling. Tell us in the chat, where are you joining us from? Let us know. We've got Switzerland, Zurich, someone else in Berlin. Hello. Netherlands, Czech Republic. Cool. We're so glad you're joining us, and I'm really excited about this talk. So we've got Hat OpenShift on IBM Z and LinuxONE. And it's my absolute pleasure to introduce our guest speaker, Daniel Soldo. And I know you're going to introduce yourself, so I'll let you do that.
Okay, thank you. Hello, everybody. I hope this is the part where I start, right? So I'll just switch to full screen. So yeah, I'm really glad to see so much activity in the chat, and some of you guys already asking if anyone is already using Red Hat OpenShift on IBM Z, and these are exactly the discussions we all want to see and want to have. So this topic today, I'm gonna try and explain a bit on a really high level. What is it all about with the OpenShift on Z platform, and why is it relevant? Why is it important? And if you are really, I don't know, part of Red Hat or part of IBM and already doing stuff on the OpenShift on Z platform, maybe it can get boring for you in some parts, but the idea is to put a lot of context into the story and to get you guys interested into it and to realize what is it all about. So before I begin, maybe just to start with a short introduction. I'm part of the IBM Böblingen R&D team the last 5 years. Grown up and raised in a Split in Croatia, and 5 years ago there was this really interesting opportunity to start working on a Linux performance analysis team on the IBM Z platform. And since last year, I'm working as the product owner for performance. And since there are a lot of different definitions probably for the role, my definition would be that I actually attend a lot of meetings, and the goal is to really identify what's the most important from all most important items. Because, I mean, everyone comes with a new request, and for everyone, their items are the most important ones. Someone has to figure it out what are actually the true most important ones. And yes, so today, talking about OpenShift on Z, this is, I was thinking about where to start with this whole story. And I think the best thing would be to get back 2 years from now. So 2 years ago, in October 2018, there was this IBM Red Hat acquisition. And it was a really big thing. I mean, I remember I think I remember it was a Sunday afternoon. And when I first saw the news, I was really shocked and excited. And I remember I was trying to explain to my girlfriend like half an hour why this deal is so groundbreaking and why this will change all our lives. But I mean, she at least pretended like she understood. But never mind. I was really excited, and what happened afterwards, it was really a wave of positive things. I mean, these are all my opinions and my views, how we in IBM, for example, experienced this. But for the first time since I was in IBM, I really saw a strong direction and a strong and good defined strategy happening. So the name of the game was hybrid multi-cloud. And I mean, we heard IBM talking about hybrid cloud really often, but with the merger from Red Hat, there was this new buzzword, hybrid multi-cloud, and it really makes sense when you think about it, because it's the reality today. If you take a look at the numbers today, you see that these are numbers from a study from BCG and McKinsey, and you can see that today there are already enterprises using the cloud in one way or the other, being it public, being private clouds, being some on-premise solutions integrated with them as well. But 94% of enterprises, they're already using some kind of clouds. And the point is, already two-thirds of all enterprises are using more than one public cloud provider. So we all know that in the recent years there was this big emergence of the public cloud, and it was quite often it was discussed like the ultimate solution to everyone's problems. But it was really soon it was seen that the public cloud is not the solution for every problem and for every enterprise. And what happened else is also that the enterprises, they noticed that everything they need, it cannot really be solved by only one public cloud provider. So today we have the reality which says that two-thirds are using more than one public cloud provider. So now we already see that the reality is multi-cloud and the reality is hybrid. But maybe the most exciting point here is that only 20% of the enterprise workloads have already moved completely to the cloud. So this is a big journey ahead of us, and also an even bigger opportunity. And there are several different analyst reports, several surveys, and one of the most interesting ones I found was the Forrester New Wave. There was a report from the fourth quarter of 2018 where they tried to compare the enterprise container platforms. And we all know how big Docker was at that time. And as you can see in this chart, the two biggest leaders have been Docker and Red Hat. Docker having a slightly stronger offering at that time, but Red Hat having a bigger market. IBM was also somewhere there. There were also other players like Pivotal, like SUSE, Mesosphere, Rancher as well. But what happened is, it's really interesting to see what happened to the market in the last 2 years. So we saw a new version of this report, and I think it was publicly available just a couple of weeks ago, maybe 1 or 2 weeks. So this is really fresh data. And here we can see that Red Hat and IBM are now seen combined here, so together, and they have by far the strongest strategy as seen by Forrester. So the strategy as at its top, and also the strongest current offering. So combining those two forces, it really made a difference. And as shown before, it's a really big market, a big opportunity, and the position of IBM and Red Hat is really good. What I found interesting to see here is also the difference, everything that changed in the last 2 years. You can see that, for example, Pivotal was acquired by VMware, still having a very strong offering. Google emerged here. Rancher was acquired by SUSE. Mesosphere, they changed the name into D2IQ, and Docker Enterprise was no longer a leader, and it's seen currently Docker Enterprise was bought by Mirantis, and it's part of the Mirantis Kubernetes offering, and the not so good adoption of Kubernetes or orchestration by Docker, and their pushing of their own Docker Swarm orchestrator was one of the reasons why Docker is not at the top anymore. And some parts of this report, they talk in more detail about the IBM and Red Hat offering. And what I found interesting is that they see it ideal for both, for two ways. So first of all, cloud native organizations and cloud native development. And the second one, it's really interesting. This is the part with large enterprises with real complex legacy applications. So for most of you who already know about the mainframes and the Z systems, you're probably aware that when talking about large enterprises with complex legacy stuff, it is quite often to talk about the mainframes. And having Red Hat and IBM with OpenShift on the mainframe, this is a real solution for a big amount of enterprises here. And this is how it looks today. I mean, and on this chart, you can have a really good overview of what both sides bring to the table. So comparing IBM and Red Hat to other cloud providers, you can see that there is only IBM and Red Hat which really offer that capabilities which are required for really being a true hybrid and multi-cloud platform. So with OpenShift and Red Hat coming to the IBM offering with these strong traditional workloads and with a good public cloud basis, what OpenShift brings to the table is the integration to all other big cloud players. So OpenShift was big before. OpenShift has a huge amount of customers running it on AWS, on Microsoft, or on Google Cloud. And it brings together that you have the flexibility to choose and run your workload wherever you like. So getting back to the traditional workloads, and it leads me to the next part, to the next section about for most of you, for the part of you who are not so familiar with IBM Z and LinuxONE, and what is it actually, and why should it be important in the context of OpenShift. And first of all, LinuxONE is, if you see the picture here, the left part is showing you the LinuxONE server, the right part is showing you the IBM Z server. So LinuxONE with the orange stripe and the Z with the blue stripe. At the first sight, it's the only difference. But when you think about it, there is not so much difference at all. So it's basically the same hardware, and it has the same capacity. The only difference is that on LinuxONE you can run only Linux workload, and on the IBM Z you can, besides Linux workload, you can also run the legacy mainframe operating systems like ZOS, VSE, TPF, KIX, and so on. And why is it actually relevant today? So the mainframes are there like more than 60, 70 years. So today they're still relevant. One of the reasons is that most of the world's corporate data resides there. So in one of the reports, I found that the fact that around 80% of world's corporate data resides on the machine. And if you take a look, you see that 92% of the top banks, almost 10 out of 10 top insurance companies, they all use the IBM Z system. And all of the big enterprises which rely on, which need a resilient server with high security capabilities and really good scalability options, for example, retail stores, airlines, governments, and so on. They are all big customers of and big fans of the IBM Z platform. And the reasons why is that so are mostly technical, because the platform provides you with a lot of features and a lot of strengths actually that can help there. One of the biggest strengths is, as mentioned, resilience. So with the IBM Z15, you have a 7 nines of uptime. So this translates to around, in average, 8 seconds per year downtime. So 8 seconds per year in average downtime. This is a piece of data which no other server on the world can achieve, and for enterprises which really rely on such kind of systems, this is a great selling point. And the additional ones are, for example, performance and scale. So in this one box, we've been able to run 1 trillion secure web transactions on a day. You can imagine Google does 6 billion searches a day. So this is like, I don't know, 180 times more on just one box. So it's a pretty powerful machine. Security is one of the reasons the mainframes really are still relevant as they were also before. Security was one of the key features of the previous machine. The topic of data breaches and data leaking out of big enterprises, we saw a couple of headlines in the last couple of years. It's getting a lot of traction, but with the Z14 and continuing with the Z15, there have been really good encryption capabilities introduced. So we have additional cores just for encryption workload. We have additional cards, so PCI-based cards just to offload different cryptographic operations. So you don't see it on your IT cost. So you don't have any additional CPU consumption with most of your workload. And the final point is a workload consolidation. So what does it mean is it's basically because of its bigger chips and bigger cores, the Z machine has, compared to traditional x86-based systems, it runs on a core with 5.2 gigahertz. It has a lot bigger caches on the chip. It has really a lot of I/O offloading capabilities. So if you compare, for example, one database workload, if you compare it, how many cores do you need on a x86-based system, you get to numbers like 5 to 10 times more x86 cores required to run the same workload as with the Z machine. And why is that important? One of the reasons is that a lot of software is priced upon the number of cores you need to run it. So if you have, for example, a database and you need 50 Intel cores to run it, you pay a yearly amount for 50 licenses. But if you can run the same database with only 6 or 7 Z cores, you pay like 7 or 8 times less for licensing fees. And this is one of the key motivators for a lot of customers to move to the Z machine. Okay, so I hope this is just a rough and a quick introduction to the Z and just a foundation to get us going on with the topic. But the topic today is, of course, OpenShift. And when it comes to OpenShift, there are a lot of different material out there, but I found this one really good explanation of OpenShift against Kubernetes. You can find it on YouTube. You can Google it. 4 essential features in 4 minutes, presented by Mo from the developer ecosystem team. And he makes really good comparisons in this video, and comparing Kubernetes, for example, to a car engine, and comparing OpenShift to a car itself. So this is, in essence, it's really what it is. So Kubernetes, it's really the engine powering OpenShift, but without OpenShift, without all the additional stuff you need, you can't really run, you can't really drive an engine on the road, right, to get from point A to point B. So just a recommendation for this video, just a really high-level introduction on it. And so here we are. What is it that OpenShift brings to the table? So a lot of automation, a lot of different services on top of Kubernetes, and it's all based on the Red Hat Enterprise Linux Core OS. So Core OS is the Linux distribution which runs on the nodes. And Kubernetes is certified to run on OpenShift, and you really have a lot of features which remove the worry of updating different parts of your cluster and being sure that you have all the same versions on all the nodes, and really. It helps a lot to maintain a cluster like this. One of the key features of OpenShift, and the idea is that OpenShift should remain same and should look the same and feel the same on any platform. So the infrastructure layer, you are agnostic to the infrastructure layer, so you don't really care, and you can't tell the difference if you're running on a public cloud or if you're running on, for example, a Z machine. So what I was missing here was the logo of the Z and LinuxONE, so I pushed it in, and now the picture is okay. Yeah, so this is IBM Z got into the ecosystem of OpenShift by the beginning of 2020. And in January, we got with the first version of OpenShift released on IBM Z, and it was the 4.2 version. And it was a week or a couple of days after the Intel release of 4.3. So there was a lot of work to do. I mean, it was the first version on the platform, and there was a lot of work to do to keep up the pace with the releases of OpenShift, but today we have OpenShift 4.5 available, and if you can see on the previous version 4.4 and the 4.5, the release cadence really split, and we are hoping to see that with 4.6, with the next release, we're gonna have the first release of OpenShift on IBM Z, which will be all par, so which will have the same versioning as the x86 based releases. And yeah, so you can see also that OpenShift has a new release each 3 months, and so this will be the same pace, which will remain also for OpenShift on Z. Yeah, and when it comes to OpenShift running on IBM Z, a very important part is the Cloud Pak idea. So Cloud Paks are really a simple but complete package of IBM certified software. So there are different versions of the Cloud Paks, and this is just a way how to consume OpenShift on Z. So this is the way OpenShift on Z is going to be sold. And they also run on any kind of system. So you don't have to worry about it. It's all OpenShift based, and it comes with the IBM certification, and it comes with the IBM service model. And this leads me to the complete picture of how the hybrid multi-cloud strategy looks at the moment, and and this is basically the ultimate goal we are all working towards. So on the lower levels, you have the infrastructure layer. So it's basically the same as it was on the slides before. The foundation is Red Hat OpenShift and all the products and add-ons which come together with OpenShift. So be it service mesh, be it serverless, pipelines, Red Hat runtimes, you name it, it's all part of the foundation. So on top of that, you have the cloud packs. So certified offerings or IBM cloud packs. You see 6 different versions here. They all come, they're still not GA. So we have today the cloud pack for multi-cloud management and the cloud pack for integration. They have been released to run on OpenShift on Z, but soon, very soon, we will have all of those cloud packs available. And I'm pretty sure a lot of customers are already in some proof of concepts and some beta testings. And this is the ultimate goal, to have it available. And on top of that, of course, come all the different services, building your workloads, managing, moving them from one cloud to another, and so on. But this is how it looks like from this perspective. And yeah, before we start with the technical overview, I'm not sure, Miriam, do we have maybe some questions I should address now, or we leave it to the end?
We can ask the audience some questions which they can. We have one question in the chat, and that's it looks like it's already been answered by a member of the audience. So a question from Enrico: is core OpenShift also the OpenShift for workers on Z? And I think Lucas has shared the sources. Under the ask a question, we have some more questions. So unless you want to touch on that question some more.
Yeah, I think I will need to exit the full screen mode if I want to see the question.
Okay, so I'll read them out to you. There's another question saying, is the IPI installer capable of handling Z?
Yeah, that's a good question. Thank you for that. So at the moment, we only have a UPI installation available on Z, and it's been worked heavily to get IPI available. And to get IPI installations available, this will be a collaboration with the IBM Cloud Infrastructure Center. So if you can find some information on the IBM CIC offering, Cloud Infrastructure Center, when we are able to get the IPI, when we are able to get OpenShift running on a infrastructure provisioned by the CIC, then the IPI will be generally available. But this is one of the goals in the next time. Okay.
There's one more question. Do you still need I don't know how to say it, 68 servers for the OpenShift control plane, or am I able to run the whole platform on Z?
The whole platform is basically running on Z, so you don't need any you don't have any x86 dependency.
Okay, great. There is one more. How can open source projects build Docker images for Z? Do you offer some sort of build service?
Yeah, so most of the images which are provided for Z and which can be built are multi-arc images. So they are built to run on multiple architectures, and this is the way Red Hat does it for all of the different architectures and different clouds supported. And to do it, I mean, there is this whole. It's a good question. Can we do it? I mean, the whole build pipeline is supported on Z as well as on x86, and they're not based on Docker anymore. They're based on Podman and using the Builder software to build the containers there. So I think, I mean, the containers can be built on any Linux system running on the Z architecture.
And I do believe another question has come in while we've been answering them. This one says, what's the preferred load balancer for a Z installation? Is there anything on board yet?
Okay, this is a fantastic question. Thank you, guys. I will be addressing this in a couple of slides. So let me leave it to that. Okay.
Great. And did you want to ask the audience a question?
I actually had a couple of questions. Yeah, I mean, if it would be really useful if you guys can tell us if you are already using OpenShift and on which cloud platform, and if you are familiar with the mainframes and do you use it? Do you work for any company using mainframes or having IBM Z systems? So this is always a good way, I don't know, to know your audience. So it would be helpful for me.
Great, thank you.
Okay, so I think I'll get going with the rest of the material, and then we can talk a little bit longer after. And okay, so let me just do a brief overview of the technical aspects of OpenShift on Z. So what's currently available is OpenShift runs on a Z13 or later. So Z13. The current model is Z15, and if you have a Z13 or later, that basically means you bought a Z machine in the last 5 years. And OpenShift is running inside of a... so first of all, we have the logical partitions. Then inside of the logical partitions, we have a ZVM hypervisor. I mean, running Linux workload, you have the alternative to run a KVM hypervisor, but OpenShift at the moment is only supported on inside of ZVM guests. So inside of the ZVM guests, you will be running the Red Hat CoreOS as the base Linux distribution, which supports then the all of the OpenShift nodes. And this leads me to the minimum setup. So this is how a minimum configuration would look like. So if you are new and new to the platform or new to the product and just want to have a quick start, for a minimum setup, you will need to have a minimum of 3 master nodes and a minimum of 2 worker nodes. You will need to have a bootstrap node for doing the setup, and after your cluster is up and running, after the cluster is alive, you can remove the bootstrap node. It won't be required for anything, but a good idea is always maybe to transform it into a worker node, or you can reuse it to run different infrastructure services like load balancing, like DNS, like DHCP services, or similar. And getting to the point of the ZVM hypervisor, and ZVM, in a way, I depicted it in this way that in ZVM you can have a vSwitch, and from the ZVM capabilities, it's also required that you use EAV for ECKD storage. EAV is extended address volume. So this is a feature of ZVM, and it should be active while installing OpenShift on the nodes. And on the LPAR layer, I put a requirements of having at least one OSA or one RoCE network adapter. So you need just to get a minimal setup, you need one network device, you need 3 masters, 2 workers, and you are set. So the master nodes, they have a minimum requirement of 4 virtual CPUs. To the worker nodes, they can be a little bit lightweighter, and they can have like 2 vCPUs. And the point is that OpenShift does require a lot of different synchronization options, a lot of monitoring, a lot of communication between the nodes, and a lot of those operations are handled by the master nodes. So you will need to you want to be assured that the master nodes have enough for the whole cluster to be healthy and to breed. Regarding the storage devices, I put here SCSI disks and DASD disks. They are both supported, so you need one of those to get your nodes installed. And regarding more storage options, so to get persistent storage for some larger amounts of data, currently only NFS is the supported option. We have spectrum scale storage as a option, which is currently in beta stage, and it will become GA soon. Of course, there is some work ongoing with the OpenShift container storage, and so on. So, but this has still to come. One point is also that there are certain external services which are required for the cluster to operate. So one of those things is also the load balancer point. With the minimum installation of OpenShift, it provides you with a software load balancer. So you get a HA proxy running in that kind of additional node which you will require. And HA proxy, DNS, DHCP, it can all be running in a Linux system. It doesn't have to be a guest inside of the ZVM for the cluster. It can also be part of a external ZVM host. It can be a external LPAR, but your cluster will gonna need those services. Usually they are already there because you already have some kind of environment and you just add your cluster into that. So this is how the minimum configuration would look like. And if you could imagine, I mean, having this kind of setup, it means that you're not really highly available if you are relying only on one logical partition. But if you take a look there, this is basically an idea how a preferred configuration for a production environment would look like. It would mean that you can distribute the nodes on 3 different LPARs. You can have 3 different LPARs with 3 different ZVM hosts, and just separate on each of those hosts one master node, because if one master node falls down, we still have additional 2, and we can recover the whole cluster. But if you have, for example, two master nodes in one, and this one goes down, then we are left with only one master node, and we don't have enough master nodes to recover the cluster. And of course, there is a recommendation to use 6 worker nodes for better performance, yes, and each of those LPARs to have at least 6 IFLs with SMT2. On the previous chart, I missed it, but it was stated that the minimum configuration is 3 IFLs, and this is really the minimum, and you should not go below that. And out of some experiences we had with OpenShift, we found out that there is a series of additional tips we could, for example, give. If you want to run a performance-sensitive workload, if you care about performance, and most of the enterprises do, and because, I mean, you run things on your IBM Z because you can get really good performance, there are also some additional stuff you should take a look at. The first one is it's a very good idea to set up infrastructure nodes. So infrastructure nodes are, besides worker and master nodes, these are the third type of nodes you can have. So each of your nodes has a label, and you can label it as infrastructure. And what it means is basically they serve, the purpose of those nodes is not to serve your workload. They're just there to take over all of the infrastructure stuff, OpenShift schedules on each of those nodes. For example, monitoring. So OpenShift has a big monitoring solution based on Prometheus and all of the different tools running their daemons, and they can be really heavy. So what we saw is that while running some latency tests, we saw that without having infrastructure nodes, those kind of monitoring instances, they are provisioned on the different worker nodes, and you never know what you get. So for example, we have been measuring latency on one worker node and seen a value, let's say 100. Measuring the same thing on the other worker node, we saw like 3 times bigger latency, like 300. And measuring on the third one, we saw like 500. So these are not tiny differences. And the answer to that is basically you should set up at least one additional infrastructure node. And the best way would be to set up 3 infrastructure nodes, because of some HA reasons. But if you migrate all of those stuff, then you have really clean worker nodes, and you get consistent performance. You get consistent latencies. So this is, I mean, depending on the application, it can really be critical. And yeah, getting back to the load balancer topic, we had some discussions with some Red Hat performance teams as well, and it's really recommended if you have performance sensitive workload and if you care about performance, to use hardware load balancers. You already have out there a lot of different hardware load balancers, for example, from F5 or from Netscaler. And F5, for example, has the series of products called Big IP. They have already integration for OpenShift implemented. So the load balancer, they not just balance the load coming outside into the cluster, they also do load balancing of the workload inside of the cluster. So they do a pretty good job. And what we heard is that it's a really valuable recommendation and a good thing to think about. Another thing is, when running inside a ZVM environment, it's important to think about hyper PAV. So if you're thinking about and already playing around with OpenShift on Z, you can try to Google it. You can try to go to the IBM Knowledge Center and get to the section with performance data. We have our site there with performance tunings, and we published also a white paper on this topic, how using different hyper PAV aliases can benefit your performance. And this is quite often, because it's a Z-specific thing, this is quite often forgotten in some setups. And the final tip is you should actually think, it's always a good thing to think about how your traffic flows between your parts of your applications, between your microservices. And if you have your big application, is the traffic happening in the cluster? Is it actually going always between different worker nodes? Or is the majority of the traffic going outside of the cluster or inside in the cluster? So if you have traffic which is east-west, so happening from one worker node to another worker node, then having a software switch like the ZVM vSwitch is probably the best option. But if you don't have traffic like that, if the most of your traffic goes outside of the cluster, then probably it's a good idea to think about dropping out the vSwitch, because if you drop it, you miss one hop, and in a network topology, having one hop less really helps the performance. So, but the point is, and this is a general statement, not just for OpenShift. It's always really valuable to evaluate the performance. So just no matter what kind of workload you're running. Okay, so yeah, now it's time for some news. So what's currently available on OpenShift on Z? It's called Red Hat Runtimes. So it's also part of one of the Cloud Packs, Cloud Pack for Application. And Red Hat Runtimes is just a set of really a lot of different frameworks for development of applications, and also backend or front-end frameworks. The runtimes are also available on the Z since June this year. So you can pick one of those and play around. And also in terms of the developer experience for OpenShift on Z, the command line interface, OpenShift Do or Odo, is also available since 2 weeks ago, and you can try it out. You can play around it with Z, and but the fascinating for me is the code-ready workspaces. I just I still haven't tried it out because it's out there on Z like 1 week ago. So it was the 2nd October. It's available. You can find information on the link here. You can. It's a integrated development environment, so an IDE inside of your browser and running directly on OpenShift on Z. So we're trying out, I guess. And the final section is why all of this works and why all of this fits together. So the adoption patterns for OpenShift and Z. So one of the biggest reasons why does it make sense to run OpenShift on Z is data gravity. So what it means is basically that it's a very good idea to move your applications closer to your data. So if you are part of an enterprise or interested in becoming one which runs IBM Z, most of your databases, or probably all, are running on the mainframe. So being it Linux or being it ZOS, the big databases, they usually run on the mainframe on the IBM Z, and it's a very good idea and to think about it and start playing around it because of a lot of different reasons, and performance probably being the reason number one. Because having your applications together with your database inside of the same box, it just means that you have really a short way from coming to your data and getting it back. So really a low response times. You can utilize networking technologies like hypersockets, where you don't have to communicate over the networking device. You can communicate directly through memory because you are sitting in the same machine. And as mentioned before, there are some of the benefits of the LinuxONE platform are consolidations. So we have here one study from the IBM IT economics team published a couple of months ago. They try to compare the costs during a 3-year time period when running OpenShift on LinuxONE and comparing it to a classic x86 environment. And if you can see the costs, they are lower, like 48% for the 3-time period. But looking at the where does the difference come from, this is more or less the whole difference comes from the software costs. So they are if you are able to run the same workload with a lot less required cores, then you of course need to pay so much less for software. And at the end of the day, the total amount of money you will need to require this, you will require to run this kind of workload, it just sinks. And of course, this kind of workload, this was a simulation of a banking application written in Java, running on WebSphere, Liberty, and so on. So this was just a simulation, and it is a point here is also that this kind of studies are also heavily dependent on the kind of workload you are having, but it's just a good proof that those stories are possible. And you may ask if you have contacts to some IBMers working in the field. Those kinds of stories are actually happening. And of course, yes, for the huge amount of ZOS systems which are there and still running at a lot of customer sites, OpenShift really presents a good possibility to modernize the platform. So we hear quite often that a lot of customers running ZOS, they are really looking to get more agility into the process, and they quite often state the speed to market and the agility as one of the biggest arguments for their modernization needs and so on. And yeah, I've been talking before already about the security capabilities of the platform. So having a platform which is capable of having that amount of security features, so and that kind of encryption performance, it's a really good addition to all of the other stuff OpenShift adds and so on. So combining those two worlds really makes sense. So I think I came to my last slide, and I can just sum it up and try. I've done it in this way. So, but spoiler alert: if you do it, this won't happen. So this was in a way pasted, but this is the way I would translate OpenShift on Z. So it's basically my translation, and it would say that it's a enterprise-ready Kubernetes on the most reliable, most powerful, and most scalable server. Maybe a lot of mosts, but never mind. It was a quick try. But for you, the last thing to do is to try OpenShift. And besides all the other platforms, we have OpenShift on Z also available. And on the link openshift.com/try, you can find all the necessary information. And for the end, just the information that we have also a red paper. It's about the big guide how to do installations on Red Hat OpenShift on Z. One of the questions was regarding IPI. I'm pretty sure, I'm pretty confident IPI will come to the IBM Z platform pretty soon. But at the moment, we are still having this user provisioned infrastructures. So there is some more manual labor to do. A lot of different references. As said, there are already a lot of material available today. So that's all what I prepared for today. Thank you all for having me, and thank you, Miriam, for the invitation. But I hope we have a couple of more questions for me to stay a bit longer here.
And thank you, Daniel. We're really happy to have you as a guest speaker here for our IBM developer channel. We do have another question. Can we get the presentation slides?
Okay. I hope you liked it, but yeah, of course I can do it. I think the best way would be to send it to you, and you can find some suitable place, or
yep, I can upload it to SlideShare or something similar to that.
Okay, yeah, would be great.
Super. And yeah, I would definitely send out to all our meetup groups a summary of the resources shared. We'll send that out. Are there any more questions from our live audience? I'll just give people a couple of seconds to type if they do have a question. We have another question under the Ask a Question function. Will the Tecton pipelines be available on IBM Z?
Oh, that's a good question. I'm currently I'm basically focused on the performance work, and I know Tecton has been discussed quite often, and it is in the works. So I can't promise that it's already there, but if it's not there, it's coming really soon. But you can ping me on my email address. I can get you the answer right away. That's maybe the best way.
And we've got a very active IBMer in the in the live
Yeah, I
stream.
see.
Elton, thank you so much for answering all the questions.
Elton,
This is
a good job. I didn't know that you were there.
We're trying out this Crowdcast platform. Like, it's fairly new for us, so it's interesting having two places with the questions. But thank you so much. Wow, all of these questions are answered. So there are now written answers. Yes, if yeah, find me on LinkedIn and Twitter. We can share those links as well with our audience. It doesn't look like there are any more questions. So thank you so much, Daniel. That was an amazing session, really filled with lots of information and great tips. Thank you.
Thanks a lot for having me, and enjoy your time, folks. And for any Z or OpenShift questions, please reach out. We are willing to talk at any time. Thank you.
Thanks, everyone. Goodbye.